I am Arvind Neelakantan. I'm going to be giving you a quick update on Unreal product roadmap or Unreal development update as we call it. So a quick introduction about myself. I think there's a lot of familiar faces over there. I am the technical account manager for Epic Games. I'm a full stack game developer making games for the last 15 years, usually providing technical direction to folks within South Asia, Middle East and Africa. And also leading instructor-led initiatives from an infrastructure point of view. So that's me, quick introduction. So let's go through some of the new features we have introduced with 5.3 and are working on what the future releases of Unreal Engine is. I'm assuming a lot of people here are here because you're using Unreal Engine. How many of you here are transitioning to Unreal Engine currently? Thank you for the transition. That's cool. So the UE5 journey to get to the new features that are ready for you today, it really took a lot of effort from us to learn from all of the previous demos that we made. So it started off with the release of Lumen in the Land of Nanite, which was a demo that was released even before Unreal Engine 5 was, the editor was production ready. And this really showed what was possible on PlayStation 5 as a tech demo even prior to the release of UE5. Then 1 year later, we went into early access and showed the capabilities with our latest demo along with our early access release to back it up. And a lot of time was spent throughout this on workflow performance. End of 2021, we released The Matrix Awakens, which is a demo which really showed the capabilities of Unreal Engine to render on a very large scale. I think there is just a second, sorry about this. I think there's a mismatch between the slide and what is being talked. If you can help with that, that'll be good. So it was essentially like creating photorealistic cities. Yeah, there you go. I think the slide is showing the previous slide of what I'm talking, yeah. Sorry about that. Hey, technical issues. Just when you're, we did like a tech check and whatnot, it's awesome, but there you go. There you go. I think, yeah. Yeah, no, it's still like a slide has to be, I think we are slightly ahead of what I'm talking about. But that's the Matrix demo. It looks awesome. We had the photorealistic cities for the first time, but also includes the real-time movie quality character animation and post-processing on a procedurally generated city. Thank you so much. Yeah. Then end of 2022, we ship Fortnite.
I see the world through my new eyes. I see the truth in them new lies. You know what it proves? We're nothing to lose. We playing it cool. In a new world, we the one making the rules. It's our turn, we gon' move earth. Make way for the rebirth. The moon is dead, let it all burn. It's a new beginning, it's a new world. It's our turn, we gon' move earth. Make way for the rebirth. The moon is dead, let it all burn. It's a new beginning, it's a new world. It's a new world.
So end of 2022, we released Fortnite using all these new things, be it Nanite, be it Lumen, and all running at 60 frames per second. And it was shipped, we shipped all of these features with Unreal Engine 5.1, which was released early 2023. And last GDC, we took procedural to the next level with our built-in procedural content generation framework, as well as matching that with a heavy foliage sample to push that side of the rendering. So if you look at all of these demos and releases, we see some of the pillars that Unreal Engine and Epic Games are really investing in. If you go back to the key features of Unreal Engine 5, specifically for games, this list really shows the areas that we've been developing towards for the initial releases of Unreal Engine 5. Now the 5th generation of Unreal Engine really is all about our next step in photorealism and content workflows, with a very special focus on how to scale for large worlds and large amount of assets. Then with those large worlds, we aim for the state-of-the-art simulation and dynamics through animation and sound. And lastly, we want to make the iteration times better, also regarding targeting platforms a lot more friendlier. Now, some of these things have been released, but some of these things are also in early states, so we'll continue to get updates and improvements. Also, we'd love to get feedback from all of the game developers who are using Unreal Engine itself. So it's a dynamic plan, and we are spinning up new areas where we can see, where we can prioritize based on the feedback that we are getting. So let's go through some of the new features that we have introduced with 5.3 and what we are working on future releases. Let's start with rendering. Rendering is one of the main drivers of Unreal Engine. We really want to keep leading the path for state-of-the graphics art, especially for games, when hitting photorealism at 60 frames per second on consoles. But outside of games, we also support high-end photorealism for other industries we are targeting, such as film and VFX, architectural visualization, product visualization, and of course, automotive. With 5.3, we are moving forward with a bunch of areas. Notable things to chat about are really nanite performance on masked textures, which has a 20% improvement in performance. Lumen also gets a number of quality of life improvements, such as lumen reflections can be now used without actually using Lumen GI, and this is especially useful for games and applications where you're using static lighting, but wish to scale up to reflection quality which is beyond just using reflection captures. And then we all have volumetric effects. Anyone who likes explosions, I'm sure everyone likes hearing explosions in their games. Yeah, there you go. And this is great. So if you're making a game which has explosions, we are transforming the cached fluid sims to get more complex effects from a single simulation. We are also now supporting path tracer to render heterogeneous volumes. We are also providing experimental support for sparse volume textures, which actually greatly speed up the caching fluid simulations and also stores voxels in less memory. Then we also have path tracer, which has a number of improvements in 5.3. Most notably that we added initial support for tracing heterogeneous volumes such as smoke, fire, clouds, and we also have experimental support with substrate materials. Talking about substrate materials, it is still in 5.3, so please do not use it in production yet, but do use it. Give us feedback on what you think about it, and we will continue to make improvements on substrate's capability, stability, and performance as we get more and more feedback from all of you. So these are some of the areas that we're working on for future releases. As the first thing, we will keep working on performance to hit 60 frames per second at more varying world setups and targeting the Gen 9 consoles. Early tessellation support is coming soon to create higher fidelity from base geometry. For instance, is there anyone who is making games that has sand or snow? If you want to have footsteps on it, this is a really good feature to have because it increases details on this lower complexity base geometry. Nanite support for variable rate shading also just missed 5.3, sorry about that, but it is going to be coming in UE 5.4. Shortly, we will also release support for nanite spline meshes. This to me is my favorite feature because I like to lay roads on my games all the time. So if you have a static mesh which you want to design using splines, this is awesome. Substrate, we plan to take this to beta next year, but we will likely first ship it in Fortnite because we like to dog food our own features first. So we'll make sure it's in Fortnite, shake off all the bugs that we might see, and then push it out to release next year. We are also planning to focus on foliage rendering research with both nanite, lumen, and shadow solutions. And in the meantime, we do plan to have the best-in-class Quixel-based foliage assets to showcase how you can set up worlds efficiently using the current tech. World building is part of UE5's pillar to create large worlds much more efficiently inside Unreal Engine. And we are offering what is called workflow creation improvements. But this also includes the ability for you to stream content seamlessly. So our ambition goal, or rather our end goal, or our ambitious goal really, is to reach millions of actors on large worlds. To hit multiple orders of magnitude more objects, we need to work on performance across the board, from adding objects to the world, which also includes physics objects, lightweight instancing, streaming improvements, and so on and so on. And with world building and 5.3, some of the improvements that you can see are that we now support nanite-based landscape meshes. So landscape tiles can actually be rendered much faster with nanite. We are also now supporting the ability to import landscapes and also to export landscapes, which has been updated to support very large landscapes and resolutions by leveraging our world partitioning system and also splitting the import operation into several successive batches. Level streaming persistence is also a plugin that manages saving and restoration of specific marked properties on objects contained with streamed in and out levels. So what does our future look like? Our future developments in the world building pillar aims to improve workflows, customization, quality and performance at any world scale density. I'm sure a bunch of you know someone who is working on a GTA clone. Right? Yes? Someone's working on an open world game. All of these features is going to be amazing for you. So workflow improvements start with the new world partitioning hash, which come with a 3D grid and level streaming support while making it easier to implement your own level streaming solution to your project. The ability to see and update your HLODs is also right inside the editor, in fact, is a long time request and we are working on it. Multiple features also in this list help world customization, such as a more advanced data layer or level instancing filters and overrides which help you do all of that. Another big topic is also to improve the quality when it comes to terrain systems that leverages all the power of nanite and our standard editing tools. So obviously our main UE5 objective remains. It needs to work efficiently and has to scale to very large, dense worlds. That's what we're working on. Which then means, how do you then populate this very large, dense world? Which is why we have the Procedural Content Generation Framework, or PCG for short. Now this was showcased in GDC. If you have seen the Electric Dreams demo at GDC, you must have seen what's going on. And this is really part of our Building Large Worlds pillar of UE5. When building detailed large worlds, you don't necessarily want to place individual assets everywhere because that will be quite impossible or very time consuming. So PCG allows developers to stay in the editor without relying on external tools and efficiently create worlds in the viewport using rules and parameters. And exciting as well is it doesn't really just work in the editor, it also works in runtime. So if you have a game where you're creating worlds procedurally, it can also happen in runtime using PCG. And so we are very excited to see what kind of games that you would be making coming from that kind of a feature. The PCG tools, of course, can also be used for linear content creation of sizable assets, such as very large architectural projects, digital twin creation, or film sets. And we will work on going forward, including UEFN support and releasing PCG content on our new Fab marketplace. By the way, if you've seen Electric Dreams, that entire project is now available, the environment that is available in the marketplace, so you can download it, kind of play around with it and see what's up. And we are hard at work at improving pretty much every aspect of PCG to expand what is possible to achieve through this framework. So let's talk about 5.3. With 5.3, we introduced hierarchical generation, which allows to distribute the graph execution at different grid sizes and share results between levels. Then with external data processing of Alembic point clouds, you can now replace our currently unsupported city sample rule processor plugin with all the benefits of PCG on top of it. We also improved on many usability aspects with subgraph debugging, loops, target actors, parameters, and so on. The list is quite long, in fact, so I definitely encourage you to take a look at the release notes of PCG with 5.3 because there's a lot of features over there. So what's the future of PCG? With the PCG framework, we are aiming to help artists, designers, and engineers build procedural tools directly in the editor, which will greatly improve world creation and world creation iteration process. At the same time, it will also help unlock new gameplay opportunities through fast and efficient runtime execution. So every time someone enters a new level or every time someone enters the game, it could literally be a new level with PCG. And to reach those goals, we are working on a full-time hierarchical generation that allows for executing hierarchical graphs from generation sources to custom policies. We are also aiming to add support for GPU compute and micro scattering, which will allow essentially more control over graph execution with defined domains and also per platform branching. While improving on this core, obviously usability is a big thing. So user experience and workflows are also attributes that we are working on, and we're also targeting to be production ready in 2024 with continued development, and more as more and more folks like yourself are using the PCG tool, we'd get a lot more feedback, and we would love to implement those feedback in the PCG tools itself. So animation, any film folks here, animation folks? I don't believe that, there's only 3, come on, 5, like, I consider myself an animator, although I'm a programmer, but I'm terrible at animation, but I love animation. So thank you for the animators, and this is for you. So animation wise, a large goal we have is to push for a full animation authoring pipeline, bypassing the need for you for most content development to rely on external DCCs. That's a big goal. And with this, what it helps is, it helps you with reducing the need for round tripping, which obviously means that there's a faster iteration time. We also unlock the ability to animate in final pixels. For traditional animators, this is awesome. So which will give creators pretty much a new superpower to fully visualize what they are creating along the way. Our animation technology is built in a flexible and extended framework. So you can also extend it using your own tools. So say you're a Python scripter, you could totally write custom tools using Python on top of this animation framework, which will then help you expand your tool chain a lot further. And we do want to see more people being able to become animators without every aspect of the tool being only available for expert usage. So when it comes to animation, what's new with 5.3? First, we're introducing the skeletal editor. Sounds weird, skeletal editor, which provides a way for users to create skeletons and also edit mesh skin weights directly inside the editor. This tool also offers faster iteration, which means that you're able to add bones to your assets, add deformation to your static meshes, and also converting them to skeletal meshes all in one place without the need for importing the skeleton data from, say, an external tool. The animation authoring inside the editor has also gotten a large number of improvements, starting from, say, smart baking keyframes to better curve editor usability and performance, and to show motion blending on animations with root motion preview when swapping root bones. We further extended the procedural toolset of control rig by providing a way for you to use the data outside of control rigs so that you can procedurally create and modify that rig anywhere else. And control rig animators can also export that file as an FBX file, which is great. And ML deformer, machine learning deformer, also got a number of improvements at 5.3, which will make it easier for you to set up training data for complex rigs. And we released a lot more content and training data that we have been using internally internally that we have been using to show you the demos. So we have now released that too. So please, check the documentation out. In Unreal Fest 2, there's been quite a few talks given on this, so definitely check it out. And looking at the future, there's a lot of improvements coming in the future with animation systems too. So animating fully in the engine simplifies and can remove the need for you to do round tripping in pipelines. This results in quite a lot of speed up in iteration time between content changes and also in gameplay. Internally, some of our game teams have begun adopting both control rig and about animating in engine. We are heavily relying on this direct feedback to rapidly improve the tool sets that the artists require to do their job efficiently. So on runtime and on gameplay quality, a long-standing push is towards motion matching support, where we have been spending a lot of time on content example data sets and also debugging tools to make the system ready to use. Our performance and our united animation pipeline we are working towards an initiative called Anim Next. So keep an eye out for it, it's pretty cool. And this is an initiative to make the anim graph logic much faster than our current rigging system, but it will also unify the control rig and the animation composition into this new framework. So when it comes to rigging, we shape our rigging workflows within the engine, and when it comes to sequencer, we will be extending the behaviors in sequencer to support dynamic user-defined operations on data to enhance your cinematic experiences that you're going to be creating. It could be linear content, or it could be even just be cutscenes. This is all cool, but how do you integrate that easily inside your game? And that's when we talk about framework. So we constantly aim to improve the efficiency and performance of creating these very complex game worlds at larger scale, because that's what we want to do. So we are investing heavily in our gameplay framework systems, and the vision is that we want to democratize our framework systems and realize a substantial and convincing tool set for you to start building AAA and large open worlds. And we get there by improving performance and work scalability and of course efficiency, and using a whole bunch of things internally, like modularization of gameplay abilities or state trees or smart objects, etc., etc. So with 5.3, we have smart objects, which essentially let your AI character understand how it should be interacting with the world, with objects inside the world. That's smart objects. And with smart objects now, they work seamlessly with world partitioning system. They work with data layers and with persistent levels. Smart objects have also been improved to support using navmesh and physics for reachability. We also have the blueprint merge tool that first works on data assets, but we now have good hopes to extend it beyond data only using blueprints. We also have the state tree now that has a dedicated debugger and also has improved breakpoint and general debugging capabilities. Beyond 5.3, we are also working on a number of areas when it comes to framework. Navmesh and Navlink to support open world and world partitioning is much better. Mass framework improvements to convert mass entities into actors and vice versa at runtime to support a far greater number of objects inside your open world. We have also been working on Mover 2.0, which is a gameplay framework tech, which is essentially a container for many of the movement nodes that you have for your AI. And we're also spearheading it with our physics-based network movement. So if you have large world, multiplayer system, you're set. The gameplay abilities frameworks are also modularized over multiple plugins, so you can use only what you want. So, and new ability for smart objects also allow for player interactions and make those interactions client-side predictable, so you can use it for multiplayer games too. Then simulation. Simulation is a core part of your creating any kind of dynamic gameplay, in addition to being very important when you're creating digital humans or when you're creating FX for both real time and for film and VFX. And with the simulation team, we have been pushing on many areas from features and interoperability with even other simulation systems like cloth, VFX, and gameplay, and as well as constantly aiming for performance. So with 5.3, we are releasing further improvements in some of the things we delivered since GDC. And some of the notable areas are really, we have improved performance in fluid dynamics, but also you have the ability to now bake those fluid dynamics. We have also introduced a new panel cloth editor, so for anyone who is fashion designers or fashion to be fashion designers or have a passion for fashion designing. And new skin weight, we now have like skin weight transfer algorithms, and we've also added what is called a XPBD, which is a constraint that is becoming common for clothing mechanisms as a basis for all of future cloth generation in engine. This provides a non-destructive cloth simulation workflow in which you can trade off speed for precision as well as getting better looking simulations when it comes to cloth. And cloth can also be now simulated and cached in the engine using the new panel cloth editor in conjunction with our existing ML deformer editor, which I showed you previously. And finally, with 5.3, we see a bunch of significant performance optimizations when it comes to destruction, because we all like explosions, we all like walls breaking. And so any kind of rigid body and overall scene query performance has been improved significantly. What's the future hold for simulation? So beyond 5.3, we are constantly working to improve our replication model to allow for large-scale networked physics worlds. So if your friend is breaking the wall in a multiplayer game, that will work, or your enemy. We've also been developing a visual debugger to help debug state of the physics worlds. We're also expanding on our vehicle system with focus on plug-and-play components to build any kind of vehicle. So if you're building a racing game, awesome. I would like to play that. We also have a new character mover system which is in progress, which supports fully physics-driven motion. And we're also add more of our ML training solutions to work with dynamic cloth and flesh simulations. And we'll continue to hammer our way on performance. And many of these areas, for instance, such as like adding objects to the physics world and streaming these very large worlds into a networked area or a network game is all work in progress that we're working on, but it's very important. So let's talk about developer iterations. So all of this is cool. You got your animation, you got your procedural content tool, you got your large world, and you got the framework together, and it's all coming together. But when you're deploying, when you're a developer, you want to be fast, you want to continue to iterate, and there has been a bunch of improvements on developer iteration itself. So some of the examples with or some of the highlights when it comes to Unreal Engine 5.3 are, first we have a multi-process cook which helps reduce the total time it takes to have a cooked output from a build farm or even from your local workstation, and that's happening by us leveraging on all available CPU cores and memory resources. Virtual assets are now production ready for Unreal Engine 5.3, and it is recommended for teams who are using Perforce and any kind of Unreal-based derived data cache, which is DDC, which will help you get the best performance. Now, beyond 5.3, we also have incremental cooking. Today, we have what is called iterative cooking for content changes. And moving forward, we're optimizing the cook process to handle incremental changes to your config and code changes to avoid recooking the same data over and over again. Target platform iteration workflows also has pretty good improvements. So new local derived data cache and cooked output store your server architecture, which allows for a network streaming of cooked data directly into your target platform, which allows for faster iteration. We also have async loading in editor and cook processes, and async loading threads optimization to increase performance for editor project loading, and plain editor or PI and cook processes have also had significant improvement. Beyond, our vision for Epic's metaverse is that we shall not be perceived as a walled garden, and goal is to allow importing and exporting data from UV and UEFN through all the standard formats that you typically see. So we are now supporting a wide array of production contests and workflows for different industries, be it games, media and entertainment, and automotive. Users' data is never locked in the UE ecosystem, and they can also always export to other systems and tools and DCCs. For example, we have like a GLTF exporter which you can use. Interchange is also a new framework for data exchange in Unreal Engine. It replaces the legacy import factories with modularized and customizable content pipeline. And interchange is now enabled by default on all 3D formats such as GLTF or OBJs, as well as texture formats. With UE 5.3, we also add support for workflows for importing and re-importing complete scenes. So if you have made something in Maya, you can bring that back into Unreal Engine and the other way too. 5.3 also allows importing USD scenes, which are referencing material X files, which also works with your USD stage actor. And there are also many incremental improvements in USD around materials and textures. And one of the cool features that I like is the last one, the NURBS tessellator, which is typically used for importing of CAD files, is now production ready. So it offers enhanced mesh quality with respect to weight. So what does the future look like when it comes to content pipeline? FBX with interchange is becoming production ready. Additional enterprise pipe tools such as Datasmith will be ported to interchange to benefit from its capabilities. And we'll also see more Material X support coming through Substrate. Then comes modeling tools. We've had animators, I'm sure there's going to be modelers. And the modeling team continues to develop new tools and workflows for designers, creators, and technical artists. And building them straight into the editor tremendously helps reduce the round-tripping times. So with 5.3, there is a new UI, which was first seen in UEFN with reorganized palettes, which has more efficient space utilization and a favorites menu. A long-standing request has been more on the selection-first approach when editing mesh elements like faces or edges or vertices, and 5.3 introduces that. Tool presets, you can now also store custom presets for tools. We also have a spline-based modeling tool where we have introduced new tools for which allows you to draw splines and also revolve tools. And these tools will continue to expand and will add more and more options into it. And then we have a bunch of improvements to vertex painting, UV displays, and normalization. So what does the future look like? The modeling tools will continue to grow with these new tools and improved UX. The improved gizmos will provide more consistent interactions between UE modes and allow for common interaction techniques. That is typically what you would see in any other digital content creation tools. And obviously a big part of Unreal Engine is that it runs on pretty much anything that has a GPU. And this also means that we will provide tools to scale content created across a wide variety of platforms. With 5.3, we have a number of improvements in this realm. First, there's mobile. Now, I won't get too deep into it because my colleague Axel is going to go deep into how Unreal Engine for mobile is going to be supported. So I'll kind of cut short on that. But let's get to XR, because XR has gotten a wide variety of updates, and some of the highlights include like Nanite can now render both on stereo views in a single pass when instant stereo rendering is enabled. Stereo improvements for lumen global illumination to leverage reusing stereo view coherency is now also improved. We also have eye tracking or eye tracked image generation with OpenXR, thus reducing the number of total pixels that needs to be shaded. So for the future, we are planning to enable desktop deferred renderer for high-end mobile devices that will also allow for mobile ray tracing support, which Axel will talk about. And again, that's only in certain Android devices. Then we are also making in-editor preview modes more precisely match with the visual fidelity of actual devices while you're in constant development. The last part of our pillar is really audio. Without an excellent sound, your game kind of might fall short. So the next generation of audio system has been very important, and we have been expanding on these feature sets and capabilities through MetaSounds, which was which has been there since our first release. And audio has some pretty major audio features which are also coming. With 5.3, we have MetaSounds output watching, which enables Blueprint and C++ to watch changes in the MetaSound graph. We also have the MetaSound Builder API, which will allow for faster iteration times where users can script and automate creation of MetaSounds as an example. And with audio bus writing, you can also take data from one MetaSound and send it to another MetaSound or to another source bus to the new MetaSound node. And so for the future, we plan to release the audio insights that enable creators working in audio to intuitively debug audio and profile your memory and your CPU to optimize your project. Then we also have MetaSound's performance improvements in the pipeline as well as workflow improvements to generally make it easier for users to iterate on MetaSounds a lot easier. So you can find a roadmap site here, which was also flashed by Shruti earlier. And this is where we announce upcoming features and we collect feedback from our developers and our users on all of those features I just walked through. We do definitely read the notes and we see the votes and the feedback, and we really see this as a way to get some data back on our plans in future releases. We plan to extend the horizon of our roadmaps towards future releases, so there will always be an overview of what's coming directionally without perhaps pegging too hard on hard releases. And we're excited that we have just released the first aspect of a future-facing roadmap that includes the thing I just talked about right now. So we'd really like to see your feedback on our future plans, so please utilize this roadmap tool and you can enter feedback on various cards in this roadmap, and we can help direct our development. So with that, thank you. I hope that gave you a good idea of what's coming. I'm looking forward to seeing your games. Next up is Axel, who's going to go deep into into how you can use Unreal Engine for developing mobile games and mobile applications. We also have some pretty exciting mobile games in our booth. So if you're ever around, do check out the booth to play the games made with Unreal Engine. So come on over, Axel.
Yeah. Thank you.
All right.